So welcome to this session. This class, we are going to discuss about the process of finding maximum and minimum values of function of two variables. So please follow through the steps so that you should be able to find answers to such problems. So minimum. So minimum and maximum values. So exclusively, we are going to discuss the process of finding these maximum and minimum values for function of two variables, x and y. So we start by defining what we mean by minimum value and maximum value of a function of two variables, x and y. So maximum value. So function of two variables, x and y, is said to have a maximum value at a point x equals to a, y equals to b, if there exists a neighborhood around this point AB, such that the value of the function at AB is always greater than the value of the function in this neighborhood. So we say a function f of x, y is said to have a maximum value at AB if there exists a small neighborhood of AB such that the value of the function at AB is always greater than the value of the function at a plus h, comma b plus k. So h is a small change in a, or small change in x, and k the small change in y. And then for minimum, value. So you say that a function f of x, comma y is said to have a minimum value at the point AB if there exists a small neighborhood of AB such that the value of the function at AB is always less than the value of the function within this neighborhood. So that's how we define the minimum and maximum values of a function. And let's also define what we mean by relative maximum and relative minimum. So relative maximum so say a function of two variables, x and y, is said to have a relative maximum at the point AB if f of xy is always less than or equals to f of AB for all points xy in a region containing the point AB or simply within the neighborhood of AB. So that's what we mean by a relative maximum of function. And then similarly, we can define relative minimum. A relative minimum so function of two variables x and y is said to have a relative minimum at the point AB if the value of the function f of xy is greater than or equals to f at AB for all points xy in the region containing AB. For all points x, y in a region containing AB. So those are the definitions of maximum value, minimum value, relative value, relative maximum and relative minimum of a function of two variables, x, y, at a point AB. So maximum and minimum values of a function are also called extreme or extremum values. Say the maximum and minimum values of a function are also called extreme values extreme values, or extremum, maximum values of a function. So extreme or extremum values of a function are the same as maximum or minimum values. So let's draw a graph to illustrate the maximum and minimum value of a function. So sketch. So this is our z axis. So this is the x, this is the y, and then this is the z, which is the function f of x, y. And then, so here we'll be describing maximum value of f of x, y at AB. And then in this other graph, so this will be y, so this 0, 0, and this x. So this z, or the function f of x, y. So this will be minimum value of the function f of x, y at AB. So here we have this. Then I have this. So this, and then here I have this. And then this is what we have. So then this is the minimum. So this is the maximum. And then here we have the minimum. So these are the sketches to represent the maximum of minimum values of function at a point AB. So this way you have the AB, this way you have the AB. And then let's also give other two definitions. So there's what we call saddle point. Saddle point or minimax. So saddle point is a point whereby the function is neither maximum nor a minimum. If you relate to the function, the case of function of a single variable, then it's the same as the point of inflection. So this is a point where a function is neither maximum nor minimum. So that's what we call the saddle point or min-max. And then the last definition is what we call, so let's see the geometrical interpretation of maximum and minimum. So, so a maximum or a minimum value. Okay, so the saddle point. So this geometrical interpretation of the saddle point here. So such a surface such a surface so the surface looks like the leather seat on the back of a horse forms a ridge rising in one direction and falling in another direction. So this is a geometrical interpretation of the saddle point. So it's a surface such that it forms a ridge rising in one direction and then falling in the other direction. So in the next session, we are going to now describe the conditions for finding the extremum values for function, and then give the rules for finding the extreme values of function. And then later on, we'll give the examples on how to find the maximum and minimum values of function f of x, y. So thank you.